Now, an important concept in science is that everything's conserved, or in other words, nothing can be created nor destroyed. So for example here, I have a pendulum. This pendulum swinging back and forth, and at certain points it has an increase of potential energy, it has an increase of kinetic energy. At the sides of the pendulum, when it's kind of stopping a little bit, is one of the greatest potential energy is present, because it stops moving for just that second. And because it stops that moving, it's at rest for just a millisecond, it has potential energy, because then it's going to swing back. But when it's at the peak of the swing, or in other words at the very bottom, it has the greatest amount of kinetic energy. Well, between those two, they're completely conserved. Whatever the potential energy is at the top of the swing, it's going to be the same amount of energy at the bottom of the swing, but those two numbers are going to equal each other. The difference is one of them's potential energy and the other's kinetic energy. Here's another example. So you have this person that's in a burning building, and so at the top of the building, they have potential energy because if they jump off, they're going to fall. Well, you might not be able to see that, but at the very top it says 10,000 joules. And then for potential energy, and the kinetic energy is 0. But as they fall, that potential energy transfers over to kinetic energy, so that at the point when they land on the trampoline to safety, all that 10,000 joules of potential energy is now 10,000 joules of kinetic energy. So just keep in mind, everything's conserved perfectly in a perfect world. It's not always perfectly conserved, but in this case, we have a complete conservation. That energy has to go somewhere.